This video covers topic 15.2, which is the transformations of quadratic functions, day 2. So you need to be on 15.2 in your notes, please. They ask us at the top to graph the following functions on your calculator and describe the change. So we have y1 equals x squared and y2 equals x plus 3 squared. Now you can plug this into y equals if you want, or we've already done it for you. So the black one is my original x squared, and then the red is x plus 3 squared. So compare your vertices, because that's what we're really looking at. From the black to the red, it moved to the left 3 units. So on your paper, you need to fill in a plus 3 on the inside shifts to the left 3 units. Now this is different than what we normally expect. Normally, if we have a positive 3, we go to the right. So you got to start getting that straight in your head, that it's the opposite of what we tend to think. Okay, so to compare the next one, x squared minus, and then x minus 3x. Black is my original, red is the change, so this time my vertex moves to the right 3 units. So down here, we put a minus 3, shifts to the right 3 units. So we had yesterday a general equation. We just had ax squared and k. Today we're adding in the h. H causes your horizontal translations on the inside. So when h is greater than 0, when it looks like this, when it looks like x minus h, because our basic original equation, you always subtract h. So h is always the opposite of what you think it's going to be. So if we have a minus h, it moves to the right because it's really minus a positive number. When h is less than 0, so if it's a negative number, but it looks like this because it's minus a negative, it's going to shift to the left. Okay, so what's happening here is we're being told, I want you to go to the right 2, and it looks like this because the minus sign is always there. Okay, now with the left, they do minus, minus, and so they've just simplified it to make it look pretty. So it's always the opposite on the inside of the parentheses. That's the only time it's going to change. Inside the parentheses is the opposite direction of what your gut instinct tells you. So to fill in the table, we've already started some of this. Plus 4 in the back is like a k. K moves up and down, just like we talked about yesterday. So up 4 here because it's behind. Now, if we want to write something that will go to the right 3 units, we need parentheses. We do the opposite sign, so normally going to the right is a positive on the x-axis, so we change it to a minus 3, and we square it. If you don't put that squared, it is wrong. To reflect across the x-axis and move up 1 unit, we would have a negative in front of the x squared and then plus 1 in the back. And in a minute, if you're starting to get confused, we're about to do a summary page that's going to summarize all of this all on one page so we can have it to reference. So a negative in front is going to reflect across the x-axis. And then a minus 2 in the back is going to shift things down 2 units. For the next one, I'm going to use a little bit of color coding so that you can see what I'm doing. In order to stretch by a factor of 4, stretch, compress, or reflect, all go in the front. And then to go to the left is going to need some parentheses. Normally when we go to the left, it's a negative 6, but this is the opposite, so we do a positive 6 because it's a minus negative 6. And then don't forget the squared up in the top because that is an important piece. So the next one's kind of long and has been done for us. Stretch by 2 in the front. Remember, big number is stretching it, making it really skinny. Fraction is making it really compressed or really fat. Minus 5 on the inside moves to the right because it's always the opposite of what we think. And then plus 7 in the back goes up 7. Compressed by a factor of 1/3. To compress, we would go in front. It does not tell me to go left, right, up, or down, so I don't need parentheses and I don't put anything else behind. And then for the last one, it's kind of an abstract thing. The negative is going to reflect the x-axis. Plus n on the inside would go to the left in units. And then minus m in the back goes down m units. So on the back, we're being given graphs and asked to write our equation. So in order to write this, I'm going to list a couple of things that are happening. First, I can see that it's being reflected because I have a max instead of a min. I can also see that my vertex shifted up 2 units. I didn't go anywhere left or right. And then remember to check your basic equation. We go 1, 1, 1, 1. If you can go out 1, down 1, out 1, down 1, and your points are on your graph, then there is no stretch or shrink. So my equation, in order to reflect, needs a negative in front. I have no left or right, so I don't need parentheses. And then to go up 2, we put a plus 2 in the back. My domain for these is always all reals, and my range is less than 2 because I start at 2 and then go down from there. For problem 5, I can see that my vertex here moved to the right 2, so I'm just going to write it over here. I went down 4. I didn't reflect, and when I go 1, 1, 1, 1, there's no stretch or shrink because the 1, 1, 1, 1 is my basic no change happening. So for my equation to go to the right, I need parentheses. I normally would do a positive 2 because it moves to the right, but anything inside the parentheses is always the opposite. And then to go down 4, I would put a minus 4 because down is the same. It's just the left or the right that are the opposites. So to identify my vertex from here, I can see it from my equation, but I'm going to show you how to do it. I'm sorry, I can see it from my graph, but I'm going to show you how to do it from the equation. Your vertex is always the opposite sign of whatever's inside parentheses. So negative 2 turns into a positive 2. And then it's the same as whatever follows. So a negative 4 follows, or a minus 4 follows. So my vertex is 2, negative 4. If I check with my graph, my vertex is at 2, negative 4. So you can identify it from a graph, but you will need to start being able to identify it from an equation as well. My axis of symmetry is always x equals x from the vertex. So it's important to get the vertex correct so that you can get your axis of symmetry correct. Problem 6, I start at 0, 0, which means I don't move right or left. I don't go up or down. If I go 1, 1, 1, 1, then there's no stretch or shrink and there's no reflect. So if nothing is happening, this is just a plain old normal x squared. Keep in mind, this is your parent function because your parent function is the one that all the other little baby equations are based off of. The parent function is where nothing is happening. No left, no right, no up, no down, no stretch, no shrink, no reflect. So my vertex is always at 0, 0 for the parent function, and my axis of symmetry is 0. X equals 0, excuse me. Okay, so keep in mind, I have nothing from parentheses and nothing that follows, which is where the zeros come from. Okay, so for problem 7, how does the graph of y1 equals 3x squared minus 5 compare with the graph of 3x squared plus 8? So we are going to put these in y equals, and I'm going to put them in order so that when I compare, they will pop up in the order I put them in, so I know which one is which. So my graph is loading. Oh, there it is. Sorry. Okay, so in y equals, I go to y equals up at the top. I'm going to put these in order. So 3x squared minus 5 is the first equation I'm seeing. and then 3x squared plus 8. Remember, the order you put them in is the order they come out in. So y1 pops up first, y2 pops up second. So when I hit graph, I really have to watch y1 and y2. So it popped up really quickly, but this was the first one, and that was the second one. So my first one is the one that is listed first here. So the first thing I need to figure out is it above, below, right, or left? So the first one I put in is this one down here, and this is below the second one. So this one falls below. So it's not above, it's not right, it's not left. Oh, look, B is my only option. The way they got 13 is this one's down at -5, this is 8, so you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 units between them. Most of the time, if you can identify above, below, left, or right, that will help you out. Not always, though. Problem 8, we kind of started it to help you see a test-taking strategy. If the graph of y equals 3/4 x minus 1 is translated up 4 units, which of the following would represent the resulting graph? Well, the only thing they've asked me to change is the fact that it's moving up 4 units. There's nothing else being changed. So the 3/4 x squared isn't being changed, which is why we can mark out A and C. Now from here, -1 plus 4 is a +3. The only one that has a +3 is answer choice B. Problem 9 asks what steps transformed the graph of y equals x squared to -3 parentheses x plus 4 squared plus 2. So if you're looking at this and you're like, oh my gosh, I've totally brain farted everything, especially on a test. Here's how you can solve it real quick. X squared, they want to know how did it change from that to this. And if you notice, I'm putting both of these in. I'm putting exactly what I see in y1. In y1 I had how does this compare to this. So I'm putting this in first and this in second. When I click graph, the first one will be x squared, the second one will be -3x. So x squared, -3x. So I can see this scooted to the left. So anything that doesn't say left needs to go. So A and B are out because they both say right. I can see this shifted up. This says left, this went up, left, and up. Okay, I can see that it is a negative, so it is reflected. Reflected. Sorry, these are really ugly. And then I can see that this one is a little bit skinnier than this one. This one's a little bit wider, so that means it would also be stretched, and C does not have a stretch. Okay, so if you forget, plug them into y equals, or you just look and you know that this reflects, this stretches left and up. Now, we're also going to fill out the purple sheet that you picked up. I'm pretty sure it's purple. Yeah, it's purple. There's a light purple sheet. It looks like this. Just doesn't have all the colors around it. So we're going to start up at the top with the translation form. So A, H, and K, we've kind of color-coded it for you here, but A points, these boxes point to A, H is on the inside, K is on the outside. So H is always the x-coordinate of your vertex. H is always written as the opposite sign, so it's always the opposite of what you really see. And it shifts your parabola. If you see a minus H, it shifts to the right. If you see a plus H, it shifts to the left. So if you see -3, that's going to the right 3. If you see +2, it's going to the left 2. So the signs are important. A in front here, if A is a positive, it will open upward, which means it will look like a U and have a minimum. And then if A is negative, it will open downward, meaning it will have a max and look like a hill. A also over here deals with stretching and compressing. If A is greater than 1, so something like 2x squared, that is going to stretch or make it narrow. We'll use narrow. just so you can remember those words mean the same thing. And then if a is between 0 and 1, like 1/2 x squared, instead of narrowing, it's going to compress it, which makes it wider. Okay. And then k, on the back part at the end, k is your y-coordinate of the vertex. If k is positive, it will shift your parabola up, and if k is negative, it will shift it down, or if k is a minus. Okay. And then on the bottom, we have the basic quadratic parent function. It goes through these points over here, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. My axis of symmetry is the vertical line that runs through the vertex. So it's always x equals a number. In this case, for your parent function, it is x equals 0. So you can see they kind of have a dotted line, but you got to zoom in to see it. So that is my axis of symmetry. My domain for all quadratics is all reals. My range for the parent function is y is greater than or equal to 0. And then your vertex is the point where the curve changes direction. Your vertex is a max when it is the highest point and a min when it is the lowest point.